Okay, using that chart for guidance, kind of as a little checklist here on problem number 7. Let's see if we can classify all the different ideas that negative 13 represents. So going down that list, first item on that list would be integers. Is negative 13 an integer by definition? Yes, it is. It's a whole number. So up here, I'm just going to list it. If you're doing the chart there, you're just checking off things as you go. Next is digits. Is that a digit? No. Right? Digits are 0, 1, 2, 3, all the way up to 9. Is it, we didn't talk about this, but is it even? Even means it has to be divisible by 2, right? Evenly divisible by 2, so this is not. It's not positive, but it is negative. Okay, rational, irrational, can't be both. Has to be one or the other. Which one is it? Okay, it's rational. If you're thinking about how that can be written as a ratio of two integers, negative 13 over 1, right? That's a ratio of two integers right there. So it's rational, it's not irrational, can't be imaginary, because rational and irrational numbers are going to be real numbers, right? So we'll be checking off real here. Natural and counting, that goes hand in hand. So if it works for one, it's going to work for the other. Are these natural or counting numbers? No. And I talked about transcendental numbers. Really the only two we're focusing in on at this point are pi and e, and that is neither. So we've listed everything we can. We've classified negative 13. Yay, we've reached our goal for today. Now, if you'd like something slightly more challenging, I mentioned this when we were defining stuff, how 0 can be interesting. Let's see if we can classify 0. Going down the list, is 0 an integer? Yes, it is. By definition, it's in there. Is it a digit? Yes, it is, because in numbers, we do see digits of 0. So it's a digit. Is it even? What's the rule if it's even? It's got to be divisible by 2 evenly, right? Turns out, it's even. Let's see, is it positive or negative? It's neither, right? So I wouldn't be checking that off. Is it rational or irrational? You sure? You sure it's rational? Should be now since I'm writing it on the board, but you can write this as a ratio of two integers, right? 0 over 1, 0 over 2, that would work. So once we know it's rational or irrational, it's not going to be imaginary. It's definitely going to be, whoops, real. Is it a natural or counting number? Remember the argument? If you're counting, normally we start at 1, but there's other circles that believe that 0 would be part of the counting or natural numbers, so we would say it's natural. It's a counting number. And then it's not transcendental. Okay, so there's some classifications. Okay, one last one I want to throw in here just to make sure we got the idea. Hopefully we do, but just to make sure. What if I have 0.999 and we keep going with that? Or another way we'd write that, 0.9 repeating, right? Like that with a little hat. Is that an integer? No, it's not a whole number, it's a decimal. It's not a digit. It's not even. It's positive though, right? So I could list that. It's not negative. Is it rational or irrational? It is rational because it's a repeating decimal, right? And if it's rational, it's real. and it's not natural counting, and it's not transcendental. So there's your classifications for number 3. All right, so here we are. We're finding the union between sets J and K. Union means we're basically bringing everything together. We're forming one set. We want all the elements from the first and the second one here brought together. So in the first set, we've got 3, we've got 12, we've got 76. We know that we want that in this set. And in the second set, we've got 3 and 12 again, which is already included, so we don't have to list that again. But then we have 94, and we have 2000. Right? That was not listed. So now when you look at the elements or the members of this set we have that's formed as the union, you compare it back to the original sets up here. Do we have everything from both sets? Okay, then we form the union. We're done. The difference between a union and an intersection, so let's look at set J here intersecting with set K, is now we only want to take what's in common between the two sets. We want to see what's overlapping between the two sets. So the intersection of J and K would be a set. As far as what's shared in common between the two sets, looks like 3 and 12, right? That's all we got. Now I thought to conclude this lesson, I'd throw a little true-false question in here because we do have some true-false in the assignment. And these are always popular, let me tell you. True or false? Is J a subset, so there's the sideways U now, of K? So how am I going to answer that? How am I going to understand that? Well, when I look at J, basically all the members I have in here, all these elements, I need to be able to see them somewhere over here in K. And for 3 and 12, I do, right? But for 76, I don't. So true or false? It's false.